Okay, let's move on to decomposition. So decomposition, much like synthesis, is exactly what it sounds like. We have one molecule, or in general, we have one molecule decomposing into two. So we have compound AB decomposing into compound A and compound B. And it's simple as that. Okay, so let's say we had that same NaCl that we had in the synthesis video. We had it, we melted it and ran an electrical current through it. Okay, this is called electrolysis. You won't need to know it in Chemistry 101. I believe so, not until later. As per our convention, you list the atoms. So you have one sodium, one chlorine, one sodium, and two chlorines. Okay, so it's literally the reverse of synthesis, pretty much. You could think about it like that in this case. So we can see here that there is only one chlorine, and there's 2 times as many over here. So simply, we multiply the only one that we have here by 2. This will also change sodium, and this will also change chlorine, which is needed. But now we have 2 sodiums here, so we've got to put another coefficient here. This makes it 2 sodiums. Now, so pretty simple like that. I just wanted to show you an example of decomposition here. So let's move on to one more example, and that'll be it. Okay, this next one's going to be a little bit more difficult, but I will give you another convention that will be useful in future reactions, such as combustion. So in this one, we have your regular old clinical hydrogen peroxide decomposing into oxygen gas and water. So this is what we call photolysis. Again, you don't need to know the specifics of that. But basically, light comes into contact with hydrogen peroxide. That's why there's an expiration label on your bottles, and it splits into water and oxygen due to the energy going into those bonds and breaking them. Okay, so as per our convention, as always, you label the atoms. So you got 2 hydrogens going in, 2 oxygens going in, 2 hydrogens going out, 1 oxygen from water going out, and 2 oxygens from oxygen gas going out. Now, before we attempt to solve this equation, we need to learn the Cho convention. That's at least what I like to call it. And this is a sequence of assigning priorities to which molecule you balance first to get the quickest and most efficient ideal balancing going in an equation. So we assign carbon the first priority, hydrogen the second priority, and oxygen the third priority. Now there's more atoms beyond this, but this is probably you're going to be dealing with these atoms in your Chemistry 101 class. So we don't have any carbons here, so we mark that off. And we have hydrogens that are already bound, so we mark hydrogen off. So we need to start with oxygen. However, hydrogen may return, okay? So starting off with oxygen, we see that there's 3 here, because remember, combined from water and oxygen gas, we have 3, but there's only 2 here. Now you may think from previous videos that we just do the common denominator thing where we cross multiply them, but you can see here that oxygen is split among 2 different species. So what we need to do is start to where oxygen is needed, which is this side. This side is deficient in oxygen. And we wouldn't do 1 because there's already a 1. We wouldn't do 3, and the reason being is that it just doesn't work out with the chemistry of this reaction and most others. So we're gonna have to bump it up to 4, but we don't need 4. So let's just start out with 2 and see what happens. So 2 times 2 hydrogens, we get 4 hydrogens. 2 times 2 oxygens, we get 4 oxygens. So we got 4 hydrogens here, 4 oxygens here, 3 oxygens here, 2 hydrogens here. So next in our priority to balance is oxygen, or well, now we have hydrogen here because oxygen is, these 2 are pretty close to each other. So now next we do hydrogen. So again, 1's already there. So let's go up to 2 and then we'll see what happens. We get 4 hydrogens and then 2 oxygens. And that just so happens to balance the equation because we get 2 plus 2 oxygens from both these species is equal to 4 oxygens. 4 oxygens here, 4 hydrogens there, 4 hydrogens there. This equation is now balanced. Okay, and that's decomposition. Thank you guys for watching, and I'll see you in the single replacement video.